Okay, so when we left, we were talking about that percentage, right? And so then if we wanted the probability that player one would win, okay, so if it's 55%, what does that leave for player one? 45. Okay, it leaves 45. Well, it should 55.
No, you're right.
All right, 55 plus 45 would equal 100%, right? That too is the complement rule. Okay, we could do 100 minus 55, or we could do 1 minus 0.55. They all mean the same thing. Okay, they all would mean the same thing. So 45 or 0.45, either one. Okay, so we could do that subtraction to find it. So like if I knew 1 was 25% or 0.25, okay, thinking like a dollar, what would the complement be? 75. Okay, so just thinking that way with how that works. All right, so let's organize our thoughts really quick, and then we'll look at a few examples, and then we're going to be good to go. Okay, so I'm going to show you some new notation that we use. Okay. All right, rock and roll. So jump back here. Let's talk about our 3 learning targets today. The first one was a probability model. Here's the thing we need to know about probability. Okay. So a lot of times we start with a fraction. We take it to a decimal. And then a percent. Okay. So probability can be represented any of those 3 ways. Okay. A fraction, a decimal, a percent. Most of us are used to doing the fraction part. Okay. 2 out of 5. 9 out of 36, 11 out of 36. Okay, so what we do there, all right? But most people in statistics do probability as a decimal, all right? And so because of that, it says that each probability is between 0 and 1. Okay, so because they use it as a decimal, we say that our probability falls somewhere between 0 and 1, 0.21, 0.37, 0.56. Okay, so it's going to fall between 0 and 1. If we have multiple probabilities for the same situation, they should add up to 1. Okay, and I think there's a problem in your assignment today where it asks probability falls between what numbers? Okay, and we would say 0 and 1. All right, so that's simple. Learning target 2 is where we talked about a complement. Okay, a complement. Well, to get a complement, we subtract the probability we know from 1. Okay, if all probabilities add up to 1 or 100, to get my complement, we just subtract what we know from 1. Okay, now here's some new notation. If the event we're using we call A, all right, could be rolling a 2, rolling a 3 on a dice. Its complement will be referenced like this. A with what looks like a C up there in the exponent piece. Okay? And we would say that is, we would read that as the complement of A or not A. Okay? So anything that's not whatever that event is. Right? And so this is our notation. Probability of, actually, let me rewrite that. Of a complement, so we'll call it AC, is 1 minus the probability of A. Okay, so subtracting what we know from 1. All right, so anytime it asks about a complement, take what you know, 1 minus what we know. All right, if we've got multiple things, we add up the things we know, subtract it from 1. Okay. And the last thing that we refer to are mutually exclusive events. And that's just a big word. Right? Mutually exclusive events. Okay? They're just basically two things that don't share any outcomes. Okay? Two things that don't share any outcomes. When we think about that first activity we did with the winning, right? The probability that player 2 wins with a 5 doesn't have any of the same answers if we looked at the chart as the probability of getting a 6 for player 2. Okay, they were exclusive. They don't share any outcomes. And so we were able to do the probability of both of those things. Actually, let's just say it's or. Probability of A or B. And that P just means probability anytime you see that. It's the probability of the first one plus the probability of the second one. That's referred to as the addition rule. Okay? We've got two things that don't share any outcomes. We just add those two probabilities together. Okay? So, what do we need to know from today? We need to know that our probabilities should fall between 0 and 1. And if I've got multiple probabilities, they should add up to 1. If I need a complement, it's 1 minus what we know. Okay? If I want to do the probability of two things, A or B, I look at each individual probability, make sure they don't share anything in common, and add them together. All right? So we're going to take a look at a couple of situations where these things are going to come into play. All right? You only have 4 problems in your assignment today, so it's not long. Okay? But I do want to just show you this, okay? Tomorrow it gets a little tricky, all right? Because we talk about what's referred to as conditional probability. You did that some in Algebra 2, not a lot, but a little. And so we're going to look at it again tomorrow, all right? And that'll be our last new material for this week. Okay, so we're only going to do 2 sections this week, new material, and then we're just going to practice it, okay? And that'll probably be how we wrap up Chapter 5, doing the same kind of thing, okay? All right, so let's take a look at this. So we've got 2 events that they've defined for us. The person has high cholesterol or the person has borderline high cholesterol. So A, I got high cholesterol. B, I'm borderline. Okay, so those are my 2 things. Then they go down here and tell me my probabilities. The probability of A is 0.16 and the probability that I'm borderline is 0.29. Okay, so they gave me 2 different events. Okay, why are those 2 things mutually exclusive? Why do they not share any people? You can only be one or the other. You can't be borderline high or high. You're either one or the other. Okay, so you can't be both. You either high or you're not. All right, you can't be high or borderline high. Okay, so we can't be both. That's why they're mutually exclusive. I can't be both things. I'm either one or the other. Okay. Because I can either be one or the other, to get the combination of both, or the probability of both, what are we going to do? We add them together. Okay? Yeah. She is smart. Okay? Probability of A plus probability of B. And the good news is they gave me those probabilities. I didn't have to find them. All right? So we would take 0.16 plus 0.29. Okay? What's that add up to be? 45? Okay? So it'd be 0.45. Okay? So we just added them together. Okay? Can't be both, high or borderline high. And to put them together, we're just going to add. Right? Now, let's look at C. Let C be the event that the person chosen has normal cholesterol. Now, they give me any kind of probability information about normal cholesterol. No, okay? They just told me if I was high or borderline high, okay? So how am I going to find the remaining category? Remaining being the key word there. Yep. We're going to subtract that last probability of both those things that we knew from 1. It should give me what's left over. So probability of C is going to be 1 minus, I got that answer, is 0.45. And so what would that leave me? 0.55, it's a complement. Okay, and that's all complement means, is subtract what you already know from 1. Okay, that's all it's telling me to do. Okay, I want to do one more with you, and then I'm going to be finished. Okay, because I think this next one's important. Okay. All right, so let's take a look at this one. Okay, so we're going to flip a fair coin 3 times. All right, so we want to give a probability model for this chance process, and then we're going to define event A as getting exactly 2 heads, okay? So when I toss the coin, I'm going to toss it 3 times in a row, okay? So I need to think about what are all the things that we could get, okay? I could have heads, I could have heads, I could have heads, and I could have tails, I could have tails, I could have tails, all right? Okay. Well, that's not going to help me. I don't like that chart. Just kidding. Just kidding. I changed my mind. All right. So let's do this one. 1, 2, 3. Okay, I like this better. Okay, so I got 3 coins. So let's think about. I could get all 3 heads. Would you agree? Yep, me too. I could keep the first one heads, the second one heads, and the last one could be tails, okay? I could keep the first one heads, the second one tails, and the last one heads. I can make the first one tails, heads, and heads. Everybody with me so far? I'm just thinking about what I could get. Yep. We could get all tails. Okay. We could do tails, heads, and tails. Head, shoulders, knees, and toes. Knees and toes. Tails, tails, and heads. Okay, and let's see, is there anything we... Heads, tails, tails? Yeah. Yep, I think that gets them all. 1, 2, 3, 4, 5, 6, 7. How many is that? 8. Okay, there's 8 different options, so my sample space is 8. Okay, now I'm going to show y'all a trick. You ready? Because let's say I had to do it 5 times. That'd be a lot of trying to figure out all the options, right? Okay, how many options do I have for the first one? I can either be what? Heads or... So I've got 2 options. How many things could I be for the second one? Heads or tails. How many could I be for the third one? Heads or tails. And what's 2 times 2 times 2? 8. Okay, so we're going to actually talk about that in a day or two. That's called the fundamental counting principle, but I'll give you a heads up start, okay, because I just think it's easier to look at it that way. Okay, that was my total options in the first coin, total options in the second coin, total options in the third. Okay, I'm either getting heads or tails each time. Okay, so let's go in and let's find the probability. I'm going to get exactly 2 heads. Okay, how many things have exactly 2 heads? There's 1, 2, 3. Is that it? Yep. So 3 out of 8. And what decimal would that be? Yep, 0.375. Okay, and that would be my probability. Okay. I think everything else is pretty straightforward. Okay, I think when we have to do multiple coins at one time, that's hard for a lot of people. It was always hard for me. Okay, but I think that'll help you a little bit. All right. Okay, so get started on your assignment. There's only 4 questions. Let's get it done. Last week, several of us just kind of took a vacation and didn't do any practice. Okay, so we need to get that done. It's starting to affect your grade if you've not gone in there and looked. Okay, I actually posted them so you could see them. All right, where we are. And I always show the overall score, like your score for the final grade, not first 9 weeks, second 9 weeks. Okay, it's always overall grade. And so you can just kind of see where you are and what needs to be done. And now we're going to take a potty break if you need to tinkle. Okay, yes, sir.